Right, let's move on to with our circle geometry for our grade 11s. We'll look at these two theorems. The angle subtended by the diameter is equal to 90 degrees. The parts of the circle becomes important here. If this is my circle, what is the diameter? It's the line that cuts the circle through the center into two equal parts. This is the center. Now this is saying the angle subtended by the diameter is equal to 90 degrees. Now if I go to the diameter and subtend an angle at the circumference, the theorem says that angle will be 90 degrees. So in other words, if I've got this angle there, so the angle that is formed here will always be 90 degrees. This is what the theorem is saying. So whenever you've got a diameter, the angle that it will form will always be 90 degrees. It doesn't matter where it comes from. If this is the diameter, this angle there is 90 degrees. So that angle is 90 degrees. Why is it 90 degrees? It is subtended by the diameter. The same diameter can subtend that angle. This angle will also be 90 degrees. The same diameter can subtend this angle. This angle will also be 90 degrees. It is subtended by the diameter. The diameter can also come this side. It can subtend this angle. So whenever we've got an angle that is subtended by the diameter, in other words, that is formed by the diameter, it is equal to 90 degrees. Look here. Remember the previous theorem. The previous theorem that we were doing, we were saying the angle at the center is twice as the angle at the circumference. This is the theorem that we were doing previously. The angle at the center, if this is the center, it is twice as the angle at the circumference. This one is 2 times bigger than that one. Now, the very same theorem. Remember that in a diameter, this is a straight line. So this angle here is how many degrees? It is 180 degrees. Where is that angle? It is at the center. And where is that other angle? It is at the circumference. Hence, this angle at the center, must be 2 times bigger than that one. So if this one is 180, surely that one must be 90. It still confirms that other theorem that an angle at the center is 2 times bigger than the angle at the circumference. So it is 2. This is called, either they call it angles in the same segment or subtended by the diameter. That's the reasons we use when we apply this kind of theorem. I want us to move on to the next one. This next one says, angles subtended by arc. Angles subtended by the same arc or chord in the same segment are equal. Let's create that scenario. If we have that scenario here, let's just create what this theorem is saying. Angles subtended by the same arc or chord in the same segment are equal. Remember, this is circle geometry. It deals with the circle. Angles subtended by the same arc or chord. Let's create the same arc or chord. If this is the chord that I'm going to be using, if it is the chord that I'm going to be using, let's look at this chord. This chord can subtend the angle there. It forms this angle. The same chord can form another angle. The same chord can also form another angle. What is the theorem saying about this scenario? Angles subtended by the same arc or chord in the same segment are equal. This is the chord that forms that angle. The same chord also forms that angle. Therefore, these two angles will be the same. They will be equal. This is what the theorem is saying. Angles subtended by the same arc or chord in the same segment are the same. What do we mean by the same segment? In other words, both of these angles must be at the same segment. Look here. If we've got a circle like this one, and we've got a chord, what is this chord doing? It divides the circle into 2 segments. The bigger segment and the smaller segment. The major segment and the minor segment. Now, this theorem is saying both angles, this chord subtends this angle. The same chord can subtend an angle here, but this does not necessarily mean that this angle will be equal to this one, because they're subtended by the same chord. The problem with this one, they're not at the same segment. This one is at the major segment, the other one is at the minor segment. So this part becomes vitally important as well, that the 2 angles that is subtended by this chord must be at the same segment. In this case, both of them are at the bigger segment, at the major segment. You can't have the one at the major segment and the one at the minor segment. Both of them must be at the same segment for them to be equal. We therefore say this angle is subtending this one subtends that one, but both of them must be where? At the same segment. Hence, when we abbreviate this theorem, we can say angles in the same segment. Both of them emphasize the fact that both of them must be in the same segment for this to be true. Remember, it may not only be the chord, it can also be the arc. Look at this arc, look at this arc. If we use the arc, this arc subtends that angle, the same arc subtends this angle. Hence, we say angle subtended by the same arc or chord. It can either be subtended by the arc or chord, but the key is that they must, both of them, be at the same segment. That's theorem number 5. If I want to prove that, let's say this is A, this is B, this is C, this is D. We want to prove that angle B is equal to angle C. As the theorem is saying, angles subtended by the same arc or chord in the same segment are equal. How would you go about proving this theorem? To prove this theorem, you must create a center. In other words, this theorem, they get on top of each other. This theorem will use the center theorem. I will have to create a center. Suppose my center, let me just create my center here. If I'm creating the center there, it means that I will have something like this. Right, this is my center. Right, that is my center. Remember what I want to prove. I want to prove that I'm required to prove that angle B is equal to angle C. This is what I want to prove. Angle B is equal to angle C. Right, I've just had my construction. I've created a center O. In other words, when I want to deal with this theorem, I will have to create a center O. Right, let's do the same. Do you see this arc? There's an angle at the center. This angle at the center, this O, let me just call O1. Let me just call that O1. We are going to say that when we start our proof, we will then have to say O1. O1 is at the center, is what? O1, yeah, it is 2 times that one. O1 is 2 times that angle. O1 is equal to 2 times angle C. Right, we are saying O1 is equal to 2 times angle C. Why is O1 2 times angle C? Because this one is, they're both subtended by this arc AD, or by this chord AD. This one is at the center, the other one is at the circumference. Now, this arc subtends this one at the center. It also subtends that one at the circumference. So angle O1 is equal to 2 angle C. Why is that? Center theorem. Number 2, let's look at O1 again. O1, which other angle does this O1 subtends at the circumference? Look here. This is the chord. It goes there first. The same chord went there. Where is the same chord going? It also goes there. So this one is at the center. This one is at the circumference. Theorem number 3. So angle O1 is also 2 times angle B. Angle O1 is equal to 2 times angle B. Right. Angle O1 is equal to 2 times angle B. Why is that the same? Reason, center theorem. Right. Look here. What is this? Okay, let's go here. What is angle O1? Angle O1 is equal to 2 angle C. At the same time, angle O1 is equal to 2 angle B. What can you say about these 2 angles? What is this angle equals to? Angle O1. This angle is equals to angle O1. So what can you say about these 2? They're the same, because they are both equals to O1. So we can safely say that angle 2B is equals to angle 2C. Why are these 2 the same? Both of them are equals to angle O1. Both equals to angle O1. Right. The next thing, you divide by 2 on both sides. If you divide this by 2, I'll be left with angle B, which is equals to angle C. If you divide it by 2, you'll be left with C. So that's how you go about proving that these 2 angles are equal. We've just done one more proof. How do I prove this? I use the center. I use the center. It is important that we realize that when we prove this, use the previous theorem that says the angle at the center is twice as the angle at the circumference. Angle at the center is twice as the angle at the circumference. Thank you.